Welcome to part 2 of problem solving with abstractions. In part 1, we saw how the farmer and his wife got the assistance of the vet to cure their cow Bessie of an illness. And we learned how we could use abstractions to solve problems by copying both experiences and code from one part to another, even if we sometimes had to abstract above the surface. Unfortunately, we got stuck when there were no more abstractions to copy, so in this episode we will have to abstract problem solving itself and learn what actually happens when we move from one level of abstraction to another. First, we should try to get an overview of how our code here moves between different levels of abstraction. Last time we did this nice for loop with collisions, and we added these also very nice functions to move the spaceship and the asteroids. And they seemed to help us a lot when we created the move shots function, both in telling us that we needed one and giving us something to copy. Of course, the delta calculation up here isn't abstracted at all. In fact, it seems very technical and awfully close to the platform. The user probably doesn't know what delta is, and honestly, I'm not too sure I do either. We can think of functions and variables with names from the problem domain as a very high level of abstraction, and code that deals directly with the platform as a very low level. Or put in another way, the harder it would be for a non-programmer to understand the words we use, the lower the level. With that in mind, let's try to get an overview of all the different levels used in this code, like a graph of how deep our diver has to go for each line. We begin at the very bottom with the delta calculation, and then immediately go to the top just below the surface with the move functions. And provided we don't dive into them, we stay near the surface until this for loop, which is a bit deeper, and then we go even deeper by diving into it. Unlike the functions, we can't just skip code that is actually there. But just like the if statement, it's only calling some other functions, rather high-level ones at that, so we don't dive too deep. Then we have all these abstracted functions. They're just defined here. We don't actually need to read them, but they are a bit in the way, like seaweed in front of our diver, something we just need to swim through. And finally, here's something to do with a visual spaceship and some translate calculation. It seems like something very close to the platform, but it's also something visual that the user will see, so it might be at the surface. And the same goes for the next for loop here. The loop itself isn't as close to the platform, but the inside of it is. That is quite a lot of swimming up and down. I know I did say that programmers should be able to move quickly up and down between levels of abstraction, but this seems a bit much. It's like our diver is almost expected to teleport between the bottom and the surface and back again. And if you know anything about diving, you know that it can be dangerous to rise too quickly and almost impossible to dive down that fast. In some ways, this reminds me of those people telling stories that seem to be all over the place. Where they talk in very specific details about whether something happens on a Wednesday or Thursday, and whether something was said by John or Jane, people you don't even know, only to suddenly become extremely vague about what actually happened, and then ending with a conclusion that seems entirely disconnected to everything else they told. Like if we had met the farmer down at the pub, and with no knowledge of his favorite cow being sick, asked him why he looked so sad. If he answered, "Oh, I'm afraid some leukocytes have entered the mammary gland, and Mr. Johnson might end up taking the farm away from us," we would have no idea what he was talking about. We'd have to ask a lot of questions, get him to explain some things in more detail, other things more abstract. Had he instead said, "Oh, it's hard times indeed. The bank has a tight hold on our assets, and our favorite cow, Bessie, has come down with some sort of sickness. I'm not sure if we can afford to lose her, but the wet isn't cheap either. He would still move quickly up and down between levels of abstraction, but he guides us by talking about the bank before mentioning assets and reminding us that Bessie is a cow before going all the way up to assets again with the problem of paying the wet. A true roller coaster ride in abstractions and emotions, but not difficult to follow or understand. When Hayakawa said that a good communicator should be able to move quickly up and down the abstraction ladder, the full quote was, "Operate on all levels of the abstraction ladder, moving quickly and gracefully and in orderly fashion from higher to lower, from lower to higher, with minds as lithe and deft and beautiful as monkeys in a tree." Note the "in orderly fashion" and the "beautiful as monkeys in a tree." Monkeys don't usually drop from the top of the tree to the bottom. If they do, something bad has happened and they'll get hurt. And they certainly don't teleport back up again. They are monkeys, not cats. A good storyteller guides us through the levels of abstractions while telling their story. They still move up and down between them, but they don't leave us confused and make us ask a lot of questions just to follow along. And in programming, we can't even ask. The code certainly won't answer. And even if we can't get a hold of the original programmer, they might not be able to remember or even know why they wrote it the way they did. Heck, it might even be our own past selves who wrote it. So we'd like the code itself to guide us, not force us on wild trips like this one, but somehow provide a smooth ride. To get some ideas on how to do that, let's focus on how we move as a diver. We can go up, down, left, right, anywhere we please between the surface and the ocean floor. But that's only because we are in the open ocean. What if we swam into a cave? Certainly, we would be much more restricted in our movements, and we would need to be a lot more careful not to get stuck or lost. In some ways, entering a function is a lot like entering a cave. From the outside, you don't know exactly what to expect, and once you're inside, you would like it to be fairly straightforward to navigate, not throwing you into loops, dead ends, or too narrow spaces. And at all times, you want a clear idea of how to exit to get back outside. Real-life divers lay lines. Basically, they carry a reel of string and connect one end to something outside the cave before entering. That way, they can always find their way back by following the line. Caves that get a lot of visits can have permanently installed lines, so that divers only need to tie their own line from the outside and onto this common line, and then follow that through the cave and back out. Of course, there are complex cave systems with a lot of interconnected caves going in different directions. In those cases, each sub-cave will have their own line installed, and when a diver leaves the common line for one of these sublines, they'll tie a bit of their own line between the two, making a jump from one to the other. The idea is that you at all times keep a complete line back to the entrance, never allowing yourself to get lost. Caves are usually created entirely without plan or structure by whatever natural forces have occurred throughout the years. But when we write our functions, we kind of design the caves that future programmers will explore, and in the absence of lines, we should try to make them as easy to navigate as possible, making them straight without sudden changes in the depth, the level of abstraction, and with optional sub-caves as function calls that divers, programmers can choose to skip over or enter as they please. We must remember that unlike cave divers, programmers that visit our code aren't there for the excitement. They are probably trying to understand and fix some problem, like we are now, and therefore we should make it as easy for them as possible. It might even be our own future selves. Even though watching a painting isn't nearly as dangerous as diving into a cave, good art actually also tries to guide us, even if we aren't aware that it does. Remember how Picasso claimed that any art, no matter how realistic or abstract, would always require the viewer to interpret it. His reason for going more abstract with Cubism was to make the viewer aware that they were doing this interpretation, to force them to acknowledge that they were doing some work. And we've seen that different kinds of art, different art styles, are also at different levels of abstraction. Those close to the real world don't require much conscious interpretation, but the more abstract, the further from the real world it becomes, the more the viewer has to work. But when it comes to a single piece of art, a single painting, everything is on the same level. Consider closing the gates at Ushimong, beat the whites with the red wedge, and yellow, red, blue. They are each at very different levels of abstraction, but when looking at them individually, each one is in a single art style at a single level of abstraction. To better understand this, here's a painting that isn't. Even without any knowledge of the art styles used, you'll probably notice that something is a bit off. There's these realistic roses and daisies and a sunflower, but then there's also this. What's going on with these blue and yellow flames? Are they also supposed to be flowers? Or maybe leaves? I'll bet that they suddenly take a lot of your attention and you become very aware that you aren't just looking at the painting, you are actively interpreting it. And you may even feel inclined to ask questions about it, like, why are those blue and yellow things there? Even if you somehow manage to ignore that part, you notice that some of the other flowers also look a bit different. I mean, what's going on here? That looks more like a failed watercolor experiment than any of the other flowers. How are they supposed to fit in? And even if you succeeded in also ignoring those, you notice that these hortensias don't look quite as realistic as the other flowers. When you look closer, they look a bit rushed, as if the artist was going for more of an impressionistic style, and you wonder why. The art styles are so different on so many different levels of abstraction that you end up spending most of your energy changing between those levels. Climbing up and down the ladder becomes the work you put into interpreting the painting, and thus you automatically think that there must be a reason for this. The different styles must be the important part of the artwork, more important than the picture itself, right? Well, in this case, it is. I intentionally created this painting, or asked an AI to produce it, to have all these different art styles, different levels of abstraction. But it could be that the artist was inexperienced, accidentally changed between styles, spent too much time on some of the details and rushed through others. Or maybe it was a collaboration between different artists who hadn't agreed on a style. This sometimes happens with movies or games where experience or quality control is a bit lackluster. But most of the time, experienced artists actually work very hard to make sure they keep their artworks in a single style, on a single level of abstraction. Of course, they might be experimenting with creating new styles. I mean, Cubo-futurism literally mixes cubism and futurism. Or they might have another reason for intentionally mixing different styles. They might actually want the viewer to be confused, want their artwork to induce this feeling of things being a bit off. Here is a rather famous example by Danish artist Asger Jorn called The Disquieting Duckling, where he took an existing painting by some other artist, done in a rather realistic style, and painted this very abstract duckling on top of it. The title is, of course, a play on Hans Christian Andersen's The Ugly Duckling, but the clash of styles between the duckling and the background makes it much more than ugly. It is, in fact, disquieting, and much more so than if it had just been the abstract duckling on its own. By the way, the painting gathered even more fame a few years ago when a third artist vandalized it by trying to add yet another layer on top, claiming that it now was their creation, like Jorn made the painting his by adding the duckling. Personally, I think this is missing the point a bit. The interesting thing about this painting isn't the layering of different artists, it's the layering of different styles, and how the viewing experience is dominated by the change in style, the change in levels of abstraction. It is supposed to feel confusing, or rather disquieting. This clashing of styles is also often used in movies, either subtly to emphasize how a character has moved from one world to another, like in The Wizard of Oz or The Matrix, where one world is in sepia tones or a greenish tint, and the other, more exciting world is in vivid natural colors. Or it can be even more exaggerated, as in Who Framed Roger Rabbit, where some characters are animated cartoons and others are real-life humans. And having a single character appear in a different style draws our attention to them, and we immediately feel that they are different. They don't fit in for some reason. The difference is the main focus for the interpretation. In comics, all the characters are often very abstract. As Scott McCloud argued, the more abstract a character is, the more relatable it becomes. But he also notes how backgrounds are often drawn in a different, less abstract style than the characters. He uses Tintin as an example, with its very realistic backgrounds, still drawn with sharply defined lines, but as if the artist were referencing the real world, in contrast with the characters, who are very stylized, especially their faces with big round noses and small black dots for eyes, much more cartoonish than the backgrounds. The idea is that we relate more to the abstract character than the realistic background. We identify with the characters and imagine that we are them, experiencing the same adventures, with the background just being, well, background. McCloud has this wonderful expression: one set of lines to see, another set of lines to be. Two different levels of abstraction at the same time, and we don't have to spend energy climbing up and down between them. We stay at one level and ignore the other. The difference in style assists us. It helps us understand that there's no need to focus on that part. In programming, even though it might accidentally happen more often than not, we don't usually intend for others to feel confused, scared, or disquieted when they read our code. And we rarely want to draw attention to something not fitting in. But when it comes to user interface code, we often have to mix two very different levels of abstraction. I mean, something as simple as a print statement is at the same time both at a very low level of abstraction, with the print statement itself being part of the platform, and at a very high level, with what is printed being something the user understands and thus up at the surface. We're so used to this that we don't even notice it. We just ignore whatever is inside the quote when we are in deep programming mode, and everything outside the text when we are in the shallow waters trying to think like a user. We even have the editor helping us by using different colors. So we get a foreground-background experience much like in the Tintin albums. This works particularly well with programming languages that have some sort of template strings that allows for mixing text with variables and expressions, like in this example that prints the number of items in your shopping basket. You have this many products in your basket. It's very easy to shift focus between foreground and background, text and code. You don't have to spend energy climbing up and down the ladder of abstraction. You can simply stay at one level and concentrate fully on your work, completely ignoring the other. We can even use complicated expressions inside the template without hurting readability, like the otherwise somewhat feared ternary operator, the question mark and colon. It's nothing more than an if-else statement, but written using symbols instead of words, so more or less impossible to read aloud, like our junior programmer otherwise would. But when used inside a template like this, you can simply ignore it, focus on the text and read it as you have this many product or products, if there's more than one, in your basket. This idea has been taken even further in modern user interface frameworks, where you can mix high-level components like a search bar or a product table directly with lower-level programming. The actual implementations aren't as clean as the template strings, but the idea is there. You ignore one level of abstraction while working on the other. You don't have to read the low-level code to understand the high-level user interface. Like you don't have to look at the detailed backgrounds in your Tintin album to understand the story. But we aren't doing modern user interface programming here, and there are more direct ways of separating different levels of abstraction. There is a principle in programming called single level of abstraction. It isn't a very strict or well-defined rule, but just the idea that everything inside of a function should be on the same level of abstraction. Just like everything in a single painting is in the same art style, or like there's only a single common diver's line in a cave. There shouldn't be any confusion to the viewer, the visitor, or the other programmers reading. They shouldn't be required to do their own abstraction or to unabstract parts of the code to understand what is going on. In some ways, this feels contrary to what Hayakawa suggests about good communicators, that they should be able to move quickly up and down, and more like what he called dead level abstracting, where speaker stays put on, well, a single level, as he quotes another author, one Wendell Johnson. The low-level speaker frustrates you because he leaves you with no directions as to what to do with the basket full of information he has given you. The high-level speaker frustrates you because he simply doesn't tell you what he's talking about. Just like the speaker or the writer or author of a story, we programmers should guide our readers. So surely we should take them on a bit of a roller coaster ride, like our friend the farmer down at the pub, right? Well, yes, but actually no. See, the difference is that when we tell a story, we control everything. We sort of force our listener to follow along up and down the ladder for the entire trip. But when we write a program, only the computer is forced to follow it line by line. The reader can choose to skip function calls like we did when we swam through the tick function to draw this graph. So our readers are more like divers in a complex cave system. They can choose to explore every nook and cranny, or they can stay with the common line and only explore a few of the subcaves, and only if they want to. We don't force them on a roller coaster with us. We give them the option to design their own ride. If forced to deal with too many changing levels of abstraction, they become exhausted and confused, forgetting the actual point because they focus so much on the change itself, like we did with this painting. But by giving them the choice, we let them focus on what is important to them, and ignore the rest, just like we were able to ignore the backgrounds or the characters when reading Tintin. So with all that knowledge about levels of abstraction, we should be ready to clean up this code and hopefully make it easy enough to understand so that we can fix whatever problems it had and finally implement this new feature. But this has been a bit of a trip through all these levels of abstraction. Hopefully not confusing, but perhaps somewhat exhausting. So this might be an excellent time for another break and once again replenish provisions before continuing the journey.